To get started, are there any questions you'd like? I'm gonna go over some of the graphical ones. Just a few more examples of that. But before we do that, we can go over some questions if you're stuck on them. Anyone?
Can you go over 9?
9?
Yeah.
Sure. Yeah. What's that's one where
I
you're
don't know. It
graphing.
was just one of the ones that I was getting lost on.
You're graphing the function, right?
Yeah. Did we? No, we didn't. No, we didn't do it in class because I've watched all of the videos and none of
Are you already at the point where you have the number line?
Yeah.
How about that? So
We did do this.
I don't know.
I think I got it. I was just confused on, I guess, if local max and local min.
Quiet down. So it looks like you've got your your problem here is so
Well,
I already did it too, but I want to figure out what's going on.
So your F prime number line is has root 3. So guys, if you already know this one and you don't want to listen to it, just do another problem. You can knock out 1 or 2 questions while I'm doing this. There's your F prime number line, and if you test that out, you're going to get decreasing, increasing, decreasing, increasing, which hopefully would agree with a 4th degree can look something like this. So I can see on your paper you've got that.
Mm-hmm.
So that looks all good. But I think the issue is your double prime number line. So when you take the second derivative, you're going to have 12x squared minus 12. Now that has 2 numbers on it. There's 2 numbers that make that equal to 0, 1 and negative 1. 0, so the problem is you do not want 0 on this number line, okay? And so if you test this out, you're going to get positive, negative, positive, which tells us, now do you see the concave up, concave down,
Yeah.
concave up? So when all is said and done, this agrees with this shape, okay? So, I know we got a different question you want me to discuss? You got yogurt on your problem set. That's good. Good feedback. Good feedback. Okay. Let's do one of the graphing ones. Of course, I misplaced my. What's up, Alyssa? Number 5. Okay. Sure.
Just like one of them.
I lost my. Oh no, here it is. Okay, thanks.
Understanding how to do this stuff, but then messing up 4 times 3, like 3 times in a row. You know, that's a move.
You sure? I don't mind going over it. Okay. It do be like that, Jesse. Yeah, if you're having trouble with graphing, try to use that noodle method. Okay. So I want to discuss 47. We can do 47, 48, but I definitely want to take some time to go over a question like 50, where you're given the derivative. So it's kind of the last big thing I need to cover. Not that you wouldn't be able to kind of figure that out, just kind of reason it out, but I do want to go over a few examples to make sure there's no confusion. But here's 47. What's up? Okay, so 47 says, here's the graph. Close enough graph, I guess. I'm sorry, it's disgusting. I can't live with it. Okay, this is the graph of F. My markers are losing their spirit. Okay, now let's graph F prime. That's not much better. Okay, so what you could do here is, this is one method that helps people if you're having trouble just getting kind of doing it more intuitively, you could list out a number, you could do a number line that fully describes the function. So what are some interesting points here? What are some numbers that might be relevant? -1 seems interesting because -1 could be an inflection point, and I'm just eyeballing it. But you see how it kind of seems like at -1, it's going from concave down to concave up.
Yeah.
And then it stays concave up, it seems like, okay, until it hits this pointy and then goes to no concavity. So -1 could be an inflection point, so that's relevant. 0 is a local min, so that's definitely relevant. And at 1, there's a local max. So this number line is kind of, I'm getting all the relevant numbers. So I'm combining the f prime number line and the f double prime number line. Now I'm going to fully describe the function. So here, the function is, it is decreasing and also concave down, okay? Between here, it is decreasing and concave up, and then it's concave up increasing, and then it's weirdly something like no concavity and decreasing. So are there any questions on how I'm filling in those regions, how they're being described? Okay. Let's translate that into, this is gonna be the hard part, so brace yourself. This was the description of f. So what if I want to describe the behavior of f prime using this exact same regions? So, hold on, so sorry. I know, I'm sure you know, but okay, so if f is decreasing, that means that the graph of f prime is negative. Okay. So try to focus hard on this one. This is pretty tough. This is one of the tougher things we do in this class. So if f is decreasing, the graph of f prime will be a negative number. Okay. If f is concave down, that means that f prime is decreasing. Okay. Now between -1 and 0, f is decreasing, so f prime is negative. This graph is concave up, and so my derivatives are increasing. So just maybe I should write this on the board as just a little reminder. This is one of the more complicated things. Okay, so f being concave up is the same as saying that f double prime is positive, which is the same as saying that f prime is increasing. So again, one of the trickier things to wrap your head around when you learn calculus is this sort of triplet of information, how that all relates. Now, of course, it's also true that if f is concave down, f double prime is negative, and f prime is decreasing. So keep going. F is increasing, so f prime is positive, and f is concave up, so f prime is increasing. Any questions so far? Are any of those confusing? Anyone? Okay. Lastly, f is decreasing, which means f prime is a negative value. And then there's no concavity, so this would be no slope, or slope is 0, I should say. Yeah, flat. Not increasing or decreasing, right? So concave up means I'm increasing, concave down means I'm decreasing. A linear f means a constant f prime. So let's try to graph it now. We'll try our best. Okay, there's -1, there's positive. There's 0. So a negative decreasing. So a little sketch might go negative decreasing, negative increasing, and then positive increasing, and then negative flat. So how can I go from positive increasing to negative flat? What has to happen? True. There has to be a jump. Notice how the derivative is jumping from a positive number to a negative number instantaneously. Does that make sense?
Yeah.
Whereas like at 0, it's changing smoothly from a negative derivative to a positive derivative. That happens smoothly, so it's going to pass through 0. So my graph is going to do something like, and also you can kind of see how the derivatives are kind of approaching zero on the far side. That's also kind of relevant. So my derivatives are going to be kind of zero over here. And so I'm trying my best here. So now I'm going to, oh, I messed up already. That's an inauspicious start, as they say. It's supposed to stay negative. So these are hard. It's a little bit easier when it's multiple choice. You can kind of just like pick key features, but you'll learn a lot more through the it's through the difficult process of trying to figure it all out. So sorry. Okay, that's actually a Humpty, where it changes from decreasing to increasing, and then it's going to pass through zero. Again, notice this little Humpty Dumpty. This local min gives us a zero derivative. And then it's going to come up like this. And then jump to a negative flat. Something like that. Okay.
And it's a, okay, so one thing there, because then it's gonna be zero.
So there's a lot of information packed in here. This is extremely dense paragraphs because it has stuff like, I mean, you can talk about this, the connection between these graphs for a long time. And I just talked about it for like 5 minutes, so. But like, for example, this graph having a local min where the derivative exists translates to a zero on the f prime graph where it changes from negative to positive. This pointy where the slope changes from positive to negative translates to a jump in the graph on the f prime and so on and so forth. Okay, you want to do another one? Yes, you would like nothing more in life
Well,
than to do another calculus problem.
That's usually how I think.
No.
I thought I lost it again. 48. These markers are killer, man. They. Huh? That's the hardest part of math is finding good markers. Yeah, that's true.
So I need chalk.
Oh, chalk is the best. Mathematicians, did you see that thing about mathematicians wanting chalk?
It makes my skin
Didn't
cold.
he
That's
like,
special Japanese
yeah,
chalk.
special
Yeah.
Japanese chalk? Now I want some.
Chalk makes my skin cold.
find some. No, I know that because the mathematicians are hoarding it. Because there's no more.
I gotta say, I do like whiteboards, just the way they feel. Chalk kind of gives me the what is that called? The tinglies? What is it called when your spine, you know, and like nails on a chalkboard? You know what I'm talking about?
See, that's what I get
Oh,
when
what are
people
those
write
things
with
called?
expo markers on paper.
Don't
Don't do
I don't think that's quite
Okay. So-
I like chalk, I have a chalkboard in my room.
There is a specific term for like when you like shiver when you hear a particularly good like.
This is the graph of that.
you like-
Let's graph F prime.
You feel like you make it. You have a thought that?
All right, ready? Anna, could you put that away, please? Thank you. What are some relevant numbers on here? This one, I'm gonna draw the number line again for you. 0 is certainly relevant, very relevant. Now what's nice about this section here is that that F is increasing and concave down concave up the whole time. So what that means is that F prime is going to be positive and increasing the whole time between negative infinity and 0. That's nice to see. Is this relevant? Where F goes from negative to positive?
Yes.
No. Certainly it seems that might be the case, but consider this argument. What if I shifted the entire graph up? Imagine I had a formula for this. Imagine I had F of X equals a bunch of stuff, complicated formula, right? Plus, and I just added like 8 to it. I shifted the whole thing up 8 units. Would that affect the derivative? No, because this thing would go to 0 when I derivative it. So Yeah. When I derived it, yeah. So that's a very not obvious fact about derivatives is that if you have a graph, things like zeros on the F graph they don't affect the derivative graph in any way, shape, or form. Okay. So anyway, we can clearly see that 1 is important, not because it's hitting 0, but it's because F is changing from decreasing to increasing instantly there. And there's a pointy, so you might make a note. Pointy, it's pointy at 1. That means what structure is going to exist on F prime? A jump, right? That's going to cause a jump. You might even jot it down now. I don't know, however your mind tends to work, you got to work with that. So if you tend to think this way, where you go, oh, I identified that, I'm immediately going to come over here and go, that's going to cause a jump on my F prime graph. Okay, this is concave up, and this is concave down. So my graph here, it goes, so increasing, decreasing, increasing means positive, negative, positive. And then concave up means increasing. Concave up means increasing. And concave down means decreasing. All right, meaningful pause. Are there any questions at all? Yes. Why isn't it? Because like this does not matter because F is changing. Sure, the value of F is changing from negative to positive, but that doesn't tell us anything about the slopes because this graph is all information about how do the slopes. By the way, here's how you can do this thing just piece by piece. You can just measure all these slopes, and every slope value is a y value on here.
Oh.
Anyway, that's really getting at the core idea here, but based on that, this equaling 0 would have no bearing on the value of its slopes. And like I also was saying, if I shifted this whole thing up so that there were no x-intercepts, it would have no effect on the derivative. So that's how, does that answer your question?
Yeah.
That's not an obvious fact at all. You might need to think about that for a while before it really starts to be like, oh, okay, I guess it actually does make sense when it's true. Okay, so let's try to draw this. A graph that's positive and increasing. Okay. Also, this whole time, F prime is positive, and then it's kind of approaching 0 on the left. So it seems like maybe something like this. Now here's where this might confuse you, but I was just kind of talking a lot about how the zeros of this graph are irrelevant. The zeros of this graph are highly relevant. Because the 0 on this graph means the derivative is 0, right? Okay, so anyway, now so I got that increasing and positive, great. Increasing but negative. And you can see, look, these are enormously negative slopes here, close to 0. Yeah. As you'll see, an asymptote on this graph tends to produce an asymptote on this graph. So, and there's going to be a jump. You can see that my final slope value is clearly a negative number. It's just negative, 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 negative. And then it jumps up to that positive thing. So, and then the derivatives are positive but decreasing. So, something like that.
I disagree.
26?
I like the idea of it.
I don't. That's a good question. You guys hear that question? Very good one. Could this hole be at 0? Now, I would argue no, because at least the way it looks to me, it can be hard to tell because you can't like zoom in like a microscope. But to me, it seems like the limit on the left-hand side, like this is always negative. However, if I redrew this so that it was kind of like sloping down to nothing, if that makes sense.
Oh.
If I had that slope really coming down, being like say the bottom of a parabola, then it would go to 0. So that's a very minor detail, but at least just looking at it, it seems like it abruptly changes from a negative slope to a positive slope.
What's wrong?
Yeah.
Why are they both
Have all my notebooks and my
Open
notes. Oh,
circles.
so excited.
These are good questions.
Because it's not like it's constant. Are you proud?
Like if you cry every time. They're both open circles because the derivative does not exist at one.
Oh, okay.
Annie.
Yeah, so symbolically, you could say these are both open holes because f prime of 1 does not exist. Okay. That's a good question. Okay. So you wanted to look at 26? Oh, yeah, for sure. You mean 49?
We did that yesterday. For sure. If you need it, you can still do it.
But sure. We just.
No, you can do it.
Cooper, you don't need to proudly announce your laziness in class at every opportunity. We know. It's a known fact. Let's look at 49. Oh, okay.
Oh, 45 makes my brain hurt. That's okay. That's gonna be hard to do on the board.
I have this one cylinder in here. At all times.
One cylinder.
So what are we doing now?
We're gonna do 49 and 50.
Okay. I have no arguments there.
If you guys, if this is just really for anyone who feels like they still want more, shh, guys, quiet, please. I'm just gonna keep going for anyone who's like, I don't know. How about this? Actually, let me change my mind. I'm gonna do 50. I think everyone probably wants to see 50 because you have to go backward.
Yes.
Oh.
And then once you're done with 50, I can do 49 if you guys want. If you're still feeling like you want to see a few more examples, but if you feel like you get it after that, you can kind of just proceed. All right. Jesse. So I need to be quiet because it's gonna be hard for me to hear. Family. Is Dylan? I don't know if Dylan Long is watching.
Dylan's
this, but
probably.
Dylan, we miss you, bro. Dylan. He's becoming a professional Twitcher. Hope that'd be sweet.
I honestly believe that he.
I
Yes,
don't know.
he does.
Hopefully.
He does. Just 2 weeks after they replaced.
Twitch is crazy because what if like the NBA, what if you had like LeBron James making $20 million a year and there were other players in the league who were just like in poverty? It'd be crazy. Like with, Twitch streamers, there's like the highest level of millionaires and then there's people that like Twitch stream full time and just making money. It's kind of interesting. I don't know.
We live in a capitalist society.
We live in a society. We live in a like if you cry every time society. Okay, 50. That's not the best drawing I've ever done, but close enough for government work, as Michael J. Knudsen would say.
Oh, goodness.
This will actually get us to an interesting idea. Has anyone thought maybe a little bit about a question like what's the derivative of an even function?
Can't say I have.
An odd function.
Oh, yeah.
Like for example, x to the fourth is an even function, right?
Yeah.
The derivative of that is 4x cubed. That's an odd function. So some food for thought. Is that always the case? Is it always true that the derivative of an even function is an odd function? And vice versa. What's the derivative of an odd function? Seems even to me. Think about the slopes, the tangent lines, and it makes some pretty good sense. Okay, so this guy's an even function, so I might be expecting his derivative to be odd. But here's the thing. This is the graph of f prime. And now we need to go and figure out what does f look like? And what does f prime look like? So let's start with f. This is our first example of the idea of an antiderivative. So that might have also occurred to you. You go, oh, we do it in this thing where it goes one way. You have a function, you take the derivative. Isn't there some way to go backward? Sure, yeah. That's our second semester will be all about that process, basically, called antiderivatives and integrals. So antiderivatives, yeah. So for example, just a quick example, the derivative of x cubed is 3x squared. Guess what the antiderivative of 3x squared is? Well, actually, it's x
Really?
cubed. It's x cubed plus a constant, technically. Because you'd say, oh, there could have been some constant added, but anyway. I don't get too ahead of ourselves here. So, okay, what does this graph tell us about the graph of f? All right, so let's start identifying let's fully describe the graph of f prime. Some relevant numbers on here. -2, so this is -2, at least I tried to make it that way.
-3.
Since it's like changing from cavity or
That's very interesting, you're pointing that out, yes. So, but here's the thing. Think about the concavity of f prime. Concavity is about the second derivative, right? So if f prime, say, has negative concavity, and you're talking about the second derivative of f prime is negative, right? What's the second derivative of f prime?
No kidding.
Right? Does that make sense?
Yes.
Yeah.
So while I'm glad you pointed that out, certainly like -1 seems to be an inflection point on this graph, but the concavity of f prime will really be telling us about the third derivative, which we're not going to concern ourselves with. But it is a thing. It certainly exists. So, but thanks for pointing it out. So what I'm really going to look at is very good, very good.
Yeah.
Because now
Is it the same?
this is the graph of f prime. So I definitely care about when is f prime negative? When is it positive? So really what I'm focusing on is when is f prime positive? When is it negative? When is it increasing? When is it decreasing? That's what I'm really focusing on. So let's look at that. Okay, so it's negative, but it's increasing. Between -3 and -2, how about here? It is positive and increasing, and then, now it's positive decreasing. Between 0 and 2, it is positive while increasing. Between 2 and 3, it is positive while decreasing, and then between 3 and infinity, it is negative while decreasing. Okay. No, there's no questions on that, right? I know. It was a lot. My favorite fictional Pokemon.
That's interesting.
It's interesting to say that, like the rest of Pokemon are not fictional.
It's true.
Well, they're real in a commercial sense. I thought that a lot was a Pokemon, was part of the Pokemon franchise, but it actually was not. It was just a meme I saw once. It's a false memory. Mandela effect. Lamau destroyed my solipsistic world right before my eyes. Terrible. Okay. Okay, so if f prime is negative, then the graph of f is. Do we know this one? If f prime is a negative value, it is decreasing. If f prime is increasing, then f is concave up. Say it one more time. If f prime is increasing, then f is concave up. How do you feel about that? Sure about that? You sure that makes sense? One more time. If f prime is increasing, f is concave up. Okay. If f prime is positive, f is increasing. If f prime is increasing, f is concave up. Okay. Let's just go. I'm gonna go through the rest. Okay. So this goes. And if I was doing this problem in practice, I was taking a test or something, I'd probably do it a bit more like this. I'd be like, okay, just looking at positiveness, negativeness. For the rest of this thing, it's gonna go plus, 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 minus. So increasing, 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 decreasing. So just focus on one property at a time. That's another way that might make more sense to you. How about just now the increasing, decreasing? So this thing goes decreasing, increasing, decreasing, decreasing. So concave down, concave up. That's an arrow. Concave down, concave up, concave down, concave down. Okay? Cool beans? And then maybe identify some spots that are really relevant. Like for example, these are some really critical values here. Spots where f prime is 0. So that would be here's 1, 2, 3, 1, 2, 3. So we know that f's gonna have Humpty Dumpties. That makes sense. Also, is this guy gonna have, this is a really critical thing. Is this guy gonna have any pointies or asymptotes or jumps or any funny business? No. Look how smooth and nicely behaved f prime is. F's gotta be smooth and nicely behaved in order for that to happen. Okay, so let's try it. I'm gonna try my best to draw this. It's gonna be tough.
We're in the same boat.
The nice thing is I can make this thing as high or low as I want, right? Because the height of this graph doesn't affect this graph. It's just all the slopes. So I might just make the whole thing positive to keep it. Oh no, I can. Hoisted by my own petard. It says that the point 0, -1 is on the graph of f. So they kind of pinned us down there. That's okay though.
It's you.
That's true. It was me.
Turns out Hall is capital T then.
Yeah. I'm using
Friggin' this is.
the royal. Is it the royal we or the royal they? I can't remember. Okay, so so looking at say extrema, local extrema are going to happen like I was just talking about at -3, 0, and 3. Oh wait, is 0? Maybe I'm wrong. Is there a local extrema at 0? If the function goes from increasing to increasing?
No.
Oh, just testing you, obviously. Lamau. But it's weird though. That's got to be an inflection point because it goes from increasing, goes concave down to concave up. So it's got to go like concave down, concave up like that. That makes sense?
Yep.
So I'm going to work my way out from the center, I think. We all have brains. They're all have different brains. So the way that you construct this connection might be a little bit different than the way I tend to think about it. I'm going to try my very best to give you some different perspectives so you can kind of piece things together in your own way. But anyway, so now let's focus on the right-hand side. Increasing concave up, then increasing concave down when I hit 0. So this is going to be some kind of inflection point at 0. So I've got to do increasing concave up and then have it swap over to increasing concave down. But then hit a local max at 3 and go to decreasing concave down. Kind of like that. So recap. This goes increasing, right? So increasing, decreasing, increasing, decreasing. And it's concave up, concave down, concave down. So you guys see that?
Mm-hmm.
And now you might be thinking, why was he talking about even and odd functions before this? Well, I mean, this seems to suggest that f is at least structurally odd looking. The problem is that it can be shifted up or down. So that's the whole plus c thing. Anyway, so if we reverse this, it's going to be I'm not sure if that makes sense what I'm talking about with the symmetry, but my inflection point is supposed to be happening at -2. Inflection point. So the inflection points are happening, right? An inflection point on f happens anywhere where f prime is changing from
Makes me so mad.
what? Increasing to decreasing, or decreasing to increasing, or increasing to decreasing. So that's why it's -2, 0, and 2.
Yeah.
What's wrong?
Nothing, just looking at my graph is hilarious.
Oh, okay, so yeah, local min there, local max there, inflection point at 2, inflection point at -2, inflection point at 0. So inflection points. Local max, local min. How do you feel about that?
Okay.
Let's do one more backward.
All right.
Let's do another backward. Yes, Laura. Oh, sorry. Then F double prime. I guess we gotta. Well, so I guess we can just finish this, but. So think about this. Don't do any calculation yet or anything. What's going to be the process for going from F prime to F double prime? It's the same process we went over on 40,
Something.
46, 47, and 48, right? Because this is just the derivative of this. So let's do it. That'll be our last thing in class today. So, okay, we've already identified a whole bunch of stuff. Here's where, if you recall earlier, Alyssa was talking about the concavity of this graph. Well, now it's relevant, right? Because if this graph, right, if this guy's concave up, right, then what's this guy doing? Increasing.
Yeah.
So again, let me write this here. Hopefully this is good. There's a statement something like, if F is concave up, then his derivative is increasing. Everyone cool with that, right? If F is concave up, then his derivative, prime, is increasing. Well, couldn't I just step that up a level and say, if F prime is concave up, then his derivative would be increasing. That's equally true, isn't it? Or could I say, if F double prime is concave up, then F triple prime. And then turtles all the way down, right? Like you could just do that as many times as you want.
Yes.
Yeah,
Yeah.
yeah. Okay, so let's construct this then.
Wow.
Told you these things are hard.
You were not wrong. I never argued with you.
Okay, so now, like Alyssa pointed out earlier, now -1 and 1 are very important.
I repeat.
Okay. So now, what parts of this graph don't matter that did matter before? -3 and 3. Because now, do I really care if this guy is positive or negative? If I'm looking at his derivative? Not really. All I care about is the slops on him. Okay? So now I really care about these values. Right? So if F prime goes increasing, decreasing, increasing, decreasing, then this graph is going to go positive, negative. Well, it's happening at -2, right? Where it changes from increasing to decreasing. So positive, negative, positive, negative. Does everyone agree with me on that?
Yeah.
Okay. Now how about concavities? Well, I guess class is over, so this would go, okay, fine. This goes concave down, concave up, concave down. And it changes here. So it's going to be decreasing, still decreasing, increasing, still increasing, decreasing, still decreasing. So the concavities on that graph tell us when this guy is increasing or decreasing. So, see you later. Have a good one. So
good luck. Thanks. Okay, Allie, we'll do it together. Thanks.